like to say good afternoon to all you folks. As Dr. J.S. pardon me, indicated, my name is Jane Froese, and I am a faculty member in the Department of Plant Science. I realize we're talking about supper here, and it's not lost on me that we've just had lunch, probably a good lunch. Unfortunately, I didn't join you there, but I had my own lunch. And maybe what's for supper is not foremost on our mind, but rather maybe a nap or something like that. Seems like a nice time. But what I'd like to do is talk about, as Dr. J.S. introduced, how will we be feeding ourselves in 25 years? Where will agriculture, and specifically where will plant science be in 25 years? So some of these questions I'd like to explore with you over the next 40 minutes or so include what foods will we be eating? Will we be eating this, will anything change in terms of our diet? How will these foods be produced? Are there any changes going to be associated with our crop production, our farming techniques? Finally, besides food, what might be the other uses of crop plants? We think of plant science, obviously food comes to mind right away. What are other uses? I'll just ask you guys, what are other uses of plant products? Okay, I hear different things. Let's have them again. Fibers, ethanol. So ethanol, a biofuel. What are other biofuels? Paper, certainly, yeah. I'm sorry? Clothes, fiber, yeah. Food, fiber, feed. What about for animals? We talk about food for people, feed for animals. Drugs, yeah. Pharma. I'm sorry, what's happening? Oxygen. Can you follow that through for me? How does it? Photosynthesis. Yep, photosynthesis. I mean, plants are our primary producers. They are what harvest sunlight, and from there we get into animal production. So I'd like to talk about where we will be. You know, for us here in Manitoba, I understand that we have, over 30 towns represented? Is that what you were saying, Dr. J.S., earlier? Represented from all over Manitoba. I'd like to consider the world as well. I think, I'll tie in moral obligations here. I think we as a society have an obligation to consider our world population, and we have a responsibility to address that. Now, 25 years from now, I started thinking about what that means for you guys. So for you folks in high school, I figure in 25 years you're going to be in your early 40s. You're going to be well on your way to a career. You're going to be there seems to be a trend to job changes. So maybe you're in your first job, second job, maybe even be in your third job. I thought about myself. Where will I be in 25 years? And I'll be exactly 65. So you know how old I am. And I went to our technician in our department who's very good with Photoshop and graphics. And I asked him, what will I look like in 25 years? And I think I got a propensity to high-necked collars, and the hairstyle might even be an improvement. But so that's sort of how I envision myself in 25 years, retiring old lady. Plant science history. I want to just do this condensed. Now I know Dr. J.S. is probably sitting there going, "I told you in the future." I said, "Not the past." But I think Dr. J.S. I have to spend a couple of minutes talking about the past, because what's that saying? If those who don't, what? I'm sorry, say it again?
Those who don't know history are doomed to repeat it.
Exactly. Those who don't know history or remember the past are doomed to repeat it. So I think I'd like to spend just a couple of minutes talking about where agriculture has been, where plant science has taken us in the past, not only centuries, but I even want to talk about millennia. Yes, those who can advocate, we've done that. This is maybe kind of a poor graph, but because I don't label the axes. But on the x-axis, because I ran out of space, x-axis is time, and we're talking from 8,000 BCE, so 10,000 years ago, all the way up to our current date, 2008. On the y-axis, I'm just talking about impact of things that have happened in agriculture, impact of things that have happened in plant science in particular. And I don't have a pointer. Is there a pointer? I did forget to bring one. Thank you. So I don't want to go through all this because I don't want to spend too much time on history, but agriculture revolution, 8,000 to 5,000 BCE. Anybody have any sense of what that was? What do I mean there, agriculture revolution? Yeah, just call it out, that's fine.
Domesticated animals and where to farm grain.
Exactly, domestication of plants and animals. And they sometimes think, how on earth did that happen? I mean, can you imagine you're hunting, you're gathering, you're totally tenuous, you're dependent upon what's around you, and what happened was Grog, going around and seeing some green plants and remembering, wow, I remember when I dropped some seed here. And was that the trigger that inspired them to think, oh, maybe we can save the seed, plant in the ground, and it will produce more. It just seems fascinating to me. Agriculture revolution. That was the institution, that's when we had a population increase, dramatic. All of a sudden there's a stable food supply. What do? We increase our population. Cities, a lessening of nomadic lifestyle. Skill specialization. Irrigation, Nile, 7000 BC, we have first reports of irrigation. Columbus, of course, that's very important for us, 1492, opening up our European immigration to the New World. Jethro Tull. Jethro Tull's a band? That's what I thought. Jethro Tull developed the first agricultural machine. You know what that was? A seeder. I've heard, yeah. Jethro Tull developed the first seeder. So here we have mechanization in agriculture. Railway in the early 1800s in the States, in the late 1800s in Canada, opening up of the West. I guess I got to be careful and not be too agricultural centric in my approach to history, but I think that agriculture undeniably plays a huge role in the opening up of Canadian prairies. Huge, rich, I don't think we appreciate it enough, huge, rich, vast soil resources, rich soil, some of the best in the world. One might argue that Ukraine has better conditions because they have higher precipitation levels, but we have incredibly rich, thick, dark, black soils. And with the railway, we have immigration and increased ability to exploit that. Liebig. Who's Liebig? High school science students should have that down? No? Their teachers should? No? Ooh, pressure. Now I've turned half the audience against me. Liebig. Liebig's law of the minimum? I'm hearing something. No? Liebig's law of the minimum. Yield is proportional to the most limiting nutrient. So if you're growing, I'll pick peas in your garden, and if the most limiting nutrient is maybe potassium, you've maybe only got 50% of the potassium that pea plant needs to produce maximum yield of peas. Then, if you only have 50% of the potassium, and that's the most limiting nutrient, the maximum yield you're ever going to get is 50%. Yield is proportional to the most limiting nutrient. He's the father of the modern fertilizer industry. Mendel. Okay. Mendel? Who is he? Genetics. Father of modern genetics. How incredible. All of a sudden we're realizing that there are these parental units, or these entities that come from the... Flashing back to, what was it, Saturday Night Live and the Coneheads, parental units? There are these entities in the parental units that control the physical characteristics, the phenotype, the genotype of the progeny in terms of yield, flower color, size, etc. Fertilizer and pesticides post-World War II. I'm a bit of a pacifist, but when I think of, and so it bothers me when I think of all the money that goes into the war machine. However, there are lots of technologies that come from the investment in war. Germany, World War I, World War II, they were looking at how do we create more bombs, shortage of nitrogen. Haber-Bosch process, industrially synthesizing nitrogen, combining hydrogen with nitrogen. And after World War II, then that nitrogen became important for fertilizer in agriculture, greatly improved yields. Green Revolution. You guys, who's heard of the Green Revolution? Maybe you can't describe it, but heard of. Yeah, so a bunch of hands. Where was the Green Revolution? Talked about the Agriculture Revolution. What about the Green Revolution? Largely in Asia, parts of India, Southeast Asia, the less developed countries of the world near to the equator. It was, and I see Dr. McVetti in the back there, and I'll be referring to him later, it was about high input agriculture. Lots of nitrogen, lots of fertilizers, lots of pesticides, increasing the harvest index. That is, channeling photosynthate to the grain part of the plant and less towards the stalks and the leaves. So we increase the harvest index, the targeted kernels. Also, we have dwarf varieties. So inputs, dwarf varieties, irrigation as well. Tremendous advances in ability to reduce food insecurity issues in the rest of our parts of the world. So I think I better move on with that history. So I guess what I'd like to say is we've got this timeline and we've got impact. I'd like to shrink that up a little bit and say what I'd like to talk about this afternoon is, where are we going in the future? And boy, is that tough to think about. Boy, is that tough to think about. I was thinking about, the creators of Star Trek, the first version of Star Trek. They had those communicators. Here we are, 2000, 2005, 2008. We've got cell phones that have video capability. I mean, they were forward-thinking, but we have, with our technology, really gone off the charts. Where are we going to go in the future? What are going to be these leaps in advances? And who is going to do that? So, what's for supper? There are some challenges. Population increase. I don't want to bore you to death with stuff that you already know, but I'm thinking about 25 years from now. In 2033, we're going to be about 8.5 billion people. This is another graph that shows, it illustrates years to doubling of our population, and we're certainly shortening that greatly, years to doubling of our population. I'd like to also highlight here, one of these drops here in I think the 1300s, that would be Black Death. That caused quite a drop in population. So we have food insecurity in the world. Is it an issue of production? No. It's an issue of distribution. We have enough food in our world to feed our population, currently. It's a matter of distribution. I think we're all very well aware of that. Standard of living increases. What happens when, we hear about standard of living increases, especially in China. There's an article in Time magazine recently about all the suburbs going up in China, and everybody's got their car going. India, standard of living increases. What happens in terms of food demand? Increases. Does it change at all? Does the kinds of foods they want to eat change? I hear no, but it's yes, and I hear some yes as well, obviously. Quality increases, amount increases, but also the protein source. That's what I want to highlight. The protein source changes. People go from wanting plant protein to wanting meat protein. Meats are, there's a loss of energy as we convert from plant protein to animal protein. So I guess the question is, in 2033, when you guys are in your early 40s, is it only going to be a matter of food distribution, or is it going to be also a matter of, do we have enough food to feed our population? Unsustainable challenges for finding something to eat for supper. Unsustainability of our current production methods. We are highly fossil fuel dependent. We are unsustainable in terms of our food production. Soil issues, we talk about erosion being huge. Water issues. Who, likes to go to the White Shell? Go canoeing. I might see you there this summer. I was at one lake, algal production, it was like green paint in the water. Eutrophication. So there are some real challenges to the sustainability of our production systems. Solutions. Well, I'm from plant science, so obviously I have this bias. But I think, plants, they are, as we said earlier, plants are our primary producers. They are where we are going to get our food from. You guys hear about that saying, we're all vegetarians. It's just that some of us like our vegetables processed through an animal first. Okay, what kinds of foods will we be eating in 2033? And boy, man, is it tough to think about what's going to happen in the future, predicting the future, boy. GMOs, genetically modified organisms. Of course, that's a huge debate. I think a year or two ago, here at the university, we had Dr. David Suzuki speak, and the auditorium was packed, full of mostly students. I imagine there were faculty members, but it seemed to me largely students. And there was huge applause, almost a standing ovation, when he got up and he said, Europe is watching the experiment in Canada and the US. They're hesitant, they're cautious about GMOs, they're watching to see what is happening in this grand experiment in Canada and the US in terms of GMO consumption. You know, there isn't long-term data. It's like laser eye surgery. Where's the long-term data? Do we know? We don't know. So, you know, wherever you stand in that, you know, pro-GMO, anti-GMO, I would argue, I put forth that GMOs are going to become ubiquitous in our society. Certainly, we know about BT corn now. BT, anybody can tell me what BT is? No? It's a bacteria, Bacillus thuringiensis. And through genetic engineering, you can actually incorporate that bacteria into plants, for example, corn. And that bacteria is poisonous to certain insects. So like the corn borer, well, here's an example. This is actually a tobacco plant. Insect is attacking the leaf of the tobacco plant, but when it's BT, this is a peanut leaf, yeah, BT peanut, the insect take a few bites, you can see some out here, and then it dies, infected from the Bacillus thuringiensis. And it's quite common. Other examples of this is current, canola. Most canola is genetically engineered, it is genetically modified largely for herbicide tolerance purposes. Golden rice, diving into a world issue. People familiar with golden rice? Heard of it? Yeah, heard of it? Beta carotene, yeah. There's a problem with vitamin A deficiency in many parts of the underdeveloped world, or less developed world. And through genetic engineering, one can place the precursors to vitamin A synthesis in this rice, and rice is a staple in these parts of the world, and in that way address this vitamin A deficiency. Now, I would come at it the other side. I'm a bit skeptic in that regard. What if we were, and I realize I have my biases, what if we were to take all the, millions of dollars to genetically engineer this golden rice and put it into development of production of leafy green vegetables, which are also a very good source of vitamin A, instead of putting all our eggs in one basket in terms of this staple already. Anyway, I realize I'm biased in different regards, but GMOs, herbicide-tolerant crops, that's another common feature in our agricultural system. How will we be producing food in 2003? This is a picture I took in Bolivia, and does it look like a field crop in Manitoba? No, what's different? Looks like weeds, yeah, because it's what? It's, you know, all these different plants, grown helter-skelter, not in rows. I'm sorry? You're right on the money. You talk about companion cropping, multi-cropping, intercropping. We've got here what? You see some corn, a couple of corn plants, and then these are faba bean plants. You can tell by the flowers, faba bean plants. Diversity. I mean, what? Diversity is good or bad? Here we have, in a lesser developed part of the world, diversity that we, with all our knowledge and fancy universities, etc., don't seem to employ in our crop producing systems. I guess what I want to hint at during the presentation is, yes, we have science and technology, abilities to do incredible things, but I think in looking to the future, we should also consider not only our past, but also less developed countries in the world, and what can we learn from them? So I think this multi-cropping is a pretty neat thing. There was a graduate student in our department did his PhD looking at, he talked about the three sisters. He was looking at, and it was a traditional South American planting system where they had a grass, that would be corn, they had a legume, which was beans, and then they added in a squash. And those three plants grown together, much like what we see here, diversity, different root systems taking nutrients and water from different levels in the soil, different nutrients being needed in greater or lesser amounts with the different plants. Stresses may affect these plants differently, and so if it's a bad year for corn, maybe the beans will do well. Things that we can learn. But of course, the difficulty, I mean, we're all set up to have a big, huge field of wheat and go in with a combine and harvest it. And so, you know, how are we going to separate the wheat from the corn? I mean, it's, you know, some engineering difficulties. But these kind of ideas. More legumes in rotation. What I've got here is a soybean root. And what are these little bulbules on the root? Does it look like a disease? No, you're right, it's not a disease. They're nodules. What's happening in those nodules? Nitrogen fixation, you bet. Bacteria, it's a symbiotic relationship between the bacteria and the roots. The bacteria infect the roots hairs, and the plant supplies carbon to the bacteria supplies nitrogen to the plant. I'll go this direction. Haber-Bosch process, what's that? Yep, I think we just talked about that a moment ago. Nitrogen combining with hydrogen. Do you know that the Haber-Bosch process, the synthetic fixation of nitrogen, takes 150 to 250 atmospheres of pressure? How many atmospheres are we at here now? We're at 1. And it takes, I think, between 400 and 500 degrees Celsius. So here we have, on one side, to synthetically fix nitrogen, what did I say, 250 atmospheres pressure and 500 degrees Celsius, whereas these little nodules, these little bacteria, they do it for free in the soil. How about including more legumes in rotation, which will fix that nitrogen, supply it to the plant, reducing our need for industrially synthesized nitrogen. Other benefits of legumes in rotation, especially perennial legumes, weed suppression, reducing the need for herbicide. Diversity, simply. This is another picture from Bolivia. I think this was potatoes and corn. This is near Lake Titicaca, where I think the Aztecs thought that that's where the sun and moon god arose from. It's kind of a funny name, too. Nitrogen fixing cereal crops. In Salina, Kansas, there's this institute called the Land Institute. And do cereals fix nitrogen, just to begin with? Do grasses fix nitrogen? No, legumes fix nitrogen. Now, they have found sugarcane, or developed sugarcane, that will fix some nitrogen. It can produce, they're saying, I think, between 60 and 80% of the nitrogen requirements for that plant. But if we can get cereals to fix nitrogen, how amazing would that be? We talked about industrial nitrogen fixation. This is Fritz Haber. I just like his picture. Doesn't he look like he's a character? Doesn't he look like there's a lot going on there? If we could produce nitrogen-fixing cereals, I'm sorry, I misspoke. I talked about the Land Institute. They're perennializing cereals. There's a gentleman who used to be in our department. He's now a research dean at St. Mary's University. Kevin Vesey, he's looking at nitrogen-fixing cereals. How incredible would that be to reduce our requirement for nitrogen fertilizer on our cereal crops? What does this look like? Where do you think we are? Prairies, yeah. Do you know that where we are now, the Red River Valley, used to be tall grass prairie, and we have less than 1% of that native prairie remaining. We have cultivated it, we have exploited it for agriculture. I'm not going against that, but I'm saying the native vegetation is tall grass prairie. Mixes of grasses with perhaps some legumes in there. Big blue stem, switchgrass, blue grama grass. What if we were perennial grasses, and then also some perennial legumes? What if we were to mimic that in our agricultural production system? What if we could mimic the original vegetative cover of the tallgrass prairie in order to capture the resources available in these shoulder periods? And I'll explain what I mean by shoulder periods. Right now, with annual cropping systems, and I'm talking about wheat, canola, barley, etc., we grow plants from mid-May till about mid-August, mid-August, mid-September. But what about March, April, and what about September, October, maybe the beginning of November, when we have some heat, when there's still some moisture in the soil, or there's good moisture in the soil, when there's still plenty of solaration? What about capturing some of that energy? What about mimicking what we have here in the natural system, protecting the soil, keeping cover, being a steward of the land? And it's this Land Institute in Salina, Kansas, where they're looking at, can they develop some perennial cereals? Can they make wheat a perennial instead of an annual, reducing the need to reseed? Organic production. Boy, do I not hesitate to open up a can of worms. I don't know where you guys are on, organic conventional production. But I think that, well, certainly organic production, in terms of the amount of food produced in our society, it's still a very small amount. I mean, most of our food is conventionally produced, but certainly the demand and the amount of organic food is increasing rapidly. There's greater demand for it. Let's see, whoops, sorry. You know, sometimes I go to farmer meetings or research meetings, and if they're talking about organic production, it seems like the organic people are very adamant we have to go organic, and herbicides, pesticides are absolutely terrible, horrible, destructive, they're giving me cancer, etc. And when you go to talk to conventional producers, oftentimes they are the polar opposite. They're sitting there going, you know, oh, those organic people, they don't know there's no way we're ever going to be able to produce foods organically. They're just living in a dream world, too much time in Wolseley. But, you know, maybe because I like to sit on the fence, I like to think that, can we not have a dialogue? Can we not reduce that polarizing effect and say, what are the advances in organic agriculture that may be applicable, that may be interesting for conventional production? For example, what about using, organic producers often use crop rotation as a way to improve the nutrient status in the soil, including forage legumes, fixing nitrogen, contributing nitrogen to the soil. What about increasing seeding rate to compete against weeds to reduce the need for herbicides? Elements, I think, of organic production can be incorporated in conventional production, and I'd like to see that dialogue develop a little better. Green Revolution version 2. Well, we should ask Dr. McVetti, who's sitting in the back, to talk about this. And if I go astray, Dr. McVetti, please set me straight. We talked a moment ago about, or near the beginning, about Green Revolution version 1. 60s and 70s, shorter varieties, high yielding, high nitrogen inputs, high fertilizer inputs, irrigation. Did a lot to improve the food security of the less developed part of the world. What about it was high input, talking about lots of synthetic inputs, and high output. Lots of product, lots of kernels of grain, rice, wheat. What about a second Green Revolution, where there is low to moderate input with perhaps not high output, but at least moderate to high output? Gets us this idea. I mean, we can think about food production feeding, you know, the 8.5 billion people in the world in 2033 in terms of, can we increase production, but also can we think about reducing our inputs to address that need so as not to further tax our environment. And I think about this diagram, which heads then into economics, and it's a little busy, but it's fairly simple to explain. On the y-axis, we've got millions of dollars. On the x-axis, we've got time from 1971 to the year 2000. And this is for Manitoba. And I can tell you for a fact that this diagram can be repeated for any province in Canada and also any state in the US. And maybe we can also go to Europe as well, though I'm less sure of that. The red line, that's farm receipts. That's gross income on the farm. And what a nice line, eh? Like, there is money to be made in farming. Doesn't that look good? 1971 to 2000. Fantastic. Let's look at the dotted green line. That's expenses. Dr. Rennie Van Acker used to be in our department, now is department head in Guelph University. He talked about capturing the wealth. The input industry is capturing the wealth that the farm is generating. So that, you know, the net effect here, net income, remains on a bit of a plateau. What about reducing inputs? That's you know, along the lines of this Green Revolution version 2, reducing the inputs in order to capture wealth. We can think about that in terms of economics. We can think about that in terms of biology, production. How much time do we have left here? 3 minutes? Okay. Just enough time to talk about this plant. What do we got here? Ham. No one's saying pot? It's all ham? Okay. Who's from around Dauphin in the group? So this is old hat to you guys, right? You guys see this all the time? Fields. Oh, sorry. You know where I wasn't going that direction. You guys.
Those are the train cars.
Those are the train cars. I've spent a little bit of time in the Dauphin area, and to me it still astounds me. You drive along and you see these fields of hemp, cannabis sativa, growing. What are we using it for? Fiber clothing. I'm sorry? Biofuels, yeah. Hemp is an amazing plant. Actually, there are no herbicides registered for it, although there's evidence that herbicides are being used in it. But hemp is it's a tall plant, very tall, and it's extremely fast growing. And in terms of weeds, what does that mean? Can't compete, exactly. So you've got these hemp plants. Once you get them going, they just take off and they outcompete the weeds. And so there's less need for herbicides. Disease and insect issues are also at a minimum relative to other crop plants. Uses of this, certainly the oils, food, but we're concentrating in Manitoba a fair bit with respect to fiber uses. Fiber matting for hanging baskets, also the composite in desktops and countertops, also buses. I mean, one of the reasons why it's kind of keen in Manitoba and Winnipeg, New Flyer Industries, the bus manufacturer in Winnipeg, they're looking at this composite made from hemp fiber because it's light and it's strong. A lighter bus, what does that mean in terms of fuel efficiency? Yeah, isn't that great? What about airplanes? Wouldn't that be fantastic? Make lighter yet strong planes. And hemp fiber, but there are questions with respect to hemp fiber, and there's a graduate student in our department looking at, wouldn't you like to be a graduate student working on hemp? Wouldn't that be kind of neat? We're looking at, what about the agronomy? What about the field production? How do we grow hemp in the field in order to maximize fiber quantity and fiber quality? What seeding rate do we need to grow it at? We know that if we increase seeding rate, we're going to have a lot of plants. They're going to be competing with each other, and they're going to grow taller than they would if there was a lower seeding rate. So what does that mean in terms of fiber quality and quantity? Do we want these taller plants? What about seeding date? When do we harvest it? Can we harvest it for seed and also fiber? Lots of questions with respect to this crop. Okay, I think I'm not going to talk about biofuel, aside to say that biofuel, I was talking to Dr. Anita Bruley-Babel, and she spoke to this group last year. And one thing she said to me, she said, Jane, you got to remember, biofuel is not a new concept. Biofuel is not new. She pointed to, third world, well, less developed countries in the world where dung is still used as a cooking fuel. It's different for us to think about that, but that's standard procedure. Wood, a biofuel. So it's sort of eye-opening for me. Climate change, stress tolerance. I think I'd like to, near the end here, keeping peace at the supper table. In Manitoba, we have a lot of people from Ukrainian background. 1932-33, what does that mean for people? You think of 32-33 Ukraine? Yeah, man-made famine. There was a famine, not because there was drought, not because there was insect pestilence, but because the Soviet government said, we require of you X tons of grain, and you will give it to us. 5 to 8 million people died in this man-made famine. Politics manipulating, using agriculture to achieve its means. Poppy production in Afghanistan. Anybody read the Manley report? I haven't. I've just heard about it on the news. I know I should. I really should. But one of the sections in there, I understand they talk about poppy production. What's the connection, poppy production? Why are we concerned about poppy production? Yeah, that farmers, and I do believe they are simply trying to make a living. Farmers trying to make a living. Poppy production, quite lucrative. However, it's, as I understand, the Taliban who are purchasing that poppy and making the profits and funding themselves through that. So in the Manley report, they say, well, how can we perhaps give farmers other options? Agriculture, plant science used to address social issues. Water for Peace in the Middle East, I've been reading in a book, it's called Rivers of Eden, and it talks about the role of water in peace in the Middle East in terms of the Nile, the Jordan, use, efficiency, irrigation, etc. I think I'll end with this. So we talked about where we're going, what's going to happen in the future, how will plant science be used to address food security issues, address what's going to be on our table in the future. And my question to you is there going to be a Henderson who works with Dr. McVetti to complete this Green Revolution version 2? Is this Henderson going to win a Nobel Prize like Norman Borlaug did for the Green Revolution version 1? Is there going to be a Dr. Fontaine who's going to come up with a biological control for late blight in potatoes, saving millions of dollars in fungicide applications? And finally, is there going to be a Bergman who completes the nitrogen fixation in wheat, making cereals something which can fix its own nitrogen, not just legumes? I can't wait to find out what you guys are going to do. With that, I'll close. I guess we might have some time for questions. And I wish you guys well as you finish your high school.